Hey guys, so I'm just going to quickly go over this week's lessons in this video. Hopefully that will help you answer all your questions, and then of course if you're still stuck, feel free to give us a shout.
Okay, so for this week's science lessons, you have 2 weeks worth of stuff. Take your time with these concepts. There's a lot, which is why you have 2 weeks. Here are your learning intentions. Now, if you look, we've got, again, 2 sets of notes and 2 sets of worksheets, and then some extra videos to help you understand everything. What I recommend is when you are done going through the notes, to watch all the videos before you attempt the worksheets. When you're done all of those pieces, I've got a real life application which I'll explain towards the end of this video. So for our first set of notes, we've got something called chemical compounds, and I'm just going to go over the aspects of the 2 different types of compounds in this PowerPoint. A compound is basically when 2 elements combine, they make something called a compound. Now, the way I think about this is these are your best friends that are always at school together, or that couple that's always at school together. It's 2 individual things coming together to make a compound. Keep in mind the compound doesn't have to have 2, it could have more combinations, but nonetheless it's these clusters coming together. Now what I really want to emphasize here are the types of compounds. So these 2 weeks of lessons are going to focus on ionic compounds. So when we're looking at something like an ionic compound, what's happening is you have something like sodium, which is a metal, and it's going to pair up with a non-metal, in this case chlorine. So that extra electron, which it wants to get rid of, so its next set of valence electrons would have 8, it decides to give it to sodium, who wants that extra electron to have its next set of valence electrons being 8. So the key thing with an ionic compound, which is what we're focusing on these set of lessons, is either the ion will gain or lose an electron. And then they're just happy and they come together and they make that compound. What I'll touch on here is there's something called a molecular compound. Here they're sharing it. They're not actually giving and taking. So ionic, gaining and losing an electron. Here they're actually sharing it. So that's super important because, like I said, we're going to focus on these compounds and we're also going to talk about how to name them. Once you're done going through this PowerPoint, there are some things for you to go through and there are some videos to help you learn. We have a worksheet to practice your skills. So for this worksheet, your first step is going to decide which of these compounds are ionic or molecular. Keep in mind, ionics will always have a metal and a non-metal kind of coming together to make a compound. And molecular, it's not going to be, it'll just be 2 nonmetals. For the second chart, what we would like you to do is to talk about the properties and sort them as to whether they're ionic or molecular compounds. So that is the first set. The second set, again, you've got your PowerPoints in your worksheet. For the PowerPoint, I'm just going to quickly explain my favorite thing, which is called the swap and drop method. So for this, picture it as your favorite rap song, as a cartoon singing it, whatever it is to get this in your memory. So when we're talking about the swap and drop method, we're specifically looking at ionic compounds. If you remember from the previous lessons, as you look at the trends in the periodic tables, the groups can tell you whether that ion is going to have a positive charge or a negative charge. So group 1, positive 1, group 2, positive 2, so on and so forth. This is the part that I mentioned in that other worksheet. 8 is great. So with this group here, their last set of electrons have 8. They don't want to lose anything. They don't want to gain electrons. They're the gold standard for this, and every other element is trying to do what they can to get to this state. So swap and drop method, I'm actually going to ignore this example and go on to the harder one. We're creating an ionic compound, so it's a combination of a metal and a non-metal. Our metal here is aluminum, and our non-metal is oxygen. So to get the charges, again, that is on your periodic table, but you can use the groups to help you. Aluminum has a +3 charge, and oxygen has a -2 charge. So the first thing we're going to do for the swap and drop method is drop the signs. So we just take out the charges. Then we're going to swap the values. So this 2 came from that oxygen, and this 3 came from the aluminum. I always draw an X. Can't really do that on this, but if that helps you, then there's another tool. And then you drop the value. So the aluminum needs 2 oxygen elements, and the oxygen needs 3 aluminum, and I'll show you what that looks like later. Now, the other aspect that can be confusing with this concept is how to name them. So the way I think about this is you have two names. You have your first name and your last name. So when it comes to naming it, the first part is your metal. That's always going to stay the same. So in this case, it's aluminum, and that just stays the same. What changes is that oxygen, the very ending, gets changed to "ide." So in this case, when you're naming it, it's aluminum oxide. And that is honestly it for that. So now let's take a look back at our class work. So you've gone through the PowerPoint. Here is the worksheet. You need a couple of materials to work on this worksheet. I have links to the actual documents if you want to print it. For those of you that don't want to deal with any of that, Ms. Troutman made this PowerPoint, which is the exact same thing as those worksheets. It's just interactive in the sense you can use your devices for it. So I'm going to use my device here. If you want to go through and use the worksheets, the same rules apply. Here I've got a set of what I like to call puzzle pieces. These ones here are all metals. And on the next one, same idea, but those are your non-metals. Our interactive version, same idea here. Here are my metals, and then my non-metals are located here. So let's go back to that PowerPoint, and I'm going to show you another example. Swap and drop method. We're looking at potassium and chlorine. So we know from our trends in the periodic table, potassium will have +1, chlorine would have a -1. And if I'm looking at my interactive tool, same thing's happening here. This little piece represents that +1 charge, and with my chlorine, that little divot represents my -1 charge. What we're going to do is take our metal and kind of just bring it there. And then we'll take our non-metal and do the same thing. And that's our compound. So the potassium and the chlorine are coming together to make a compound. If we go back to our PowerPoint, we know we need to drop the signs. So there we go. We swap the values. And we get something that looks like this. Now, just like Miss Inkster always says in math classes, there's always that invisible one. Just like math and chemistry, we don't write those ones. Now, when it comes down to naming it, the potassium would still be potassium because that's the metal. And the non-metal is the chlorine ion, which we swap the ending to be chloride. So the whole compound together is potassium chloride. Now let's take a look at that worksheet. We put the puzzle pieces together. We have our ion name. We put the group number in. We know where the metals and the non-metals are located. And then we have to name the compound. In this case, it's potassium chloride. And so what we're going to ask you guys to do is to do the same thing with the other elements that are in that interactive tool. And like I said, before you attempt any of the worksheets, watch these videos. So you're probably coming down towards your end of your 2 weeks. I have my real life application question, and some of you might have seen I posted this a little bit earlier than I was supposed to. For the question, what I'm asking is when we eat something super high in sodium, two things happen. We become thirsty and our blood pressure tends to rise. What I want you guys to do is to tell me, based on what you know of ions, why do we get thirsty and why does that affect our blood pressure? And just to give you an idea of the foods that may cause that, here are some examples. So often it's when you eat these kind of meals, especially if it's like your takeout meals, or in our case now, probably like your food delivery apps. So why is it that when you eat these foods, we tend to become more thirsty and our blood pressure goes up? So I hope that helps. If you guys like these videos to start off the week, let us know and we'll make more of them. And of course, if you're ever struggling, please feel free to message us. We're honestly here to help you. So until then, I'll see you guys later. Bye.